Assalamu alaikum everyone. Welcome to my presentation on hand gesture and facial emotion based human computer interaction to control real life application. I'm Sanjida Islam, roll 1510016. My supervisor is Abdul Mutin sir, assistant professor from Department of Electrical and Computer Engineering, Russia University of Engineering and Technology. And this is the outline of the presentation. Human computer interaction is nothing but a system where human can interact with the computer in a more efficient way, like two humans interacting with each other. And we know that in a computer there are input-output devices, a memory and processing unit, but without the instruction given by a human, the computer cannot actually perform anything. And we need actually some input devices to actually give these instructions to this computer, and they are like mouse, pointer, keyboard, etc. And these are like barriers between human and computer. So we can actually use some gesture-based system to actually remove this barrier. And this is my proposed system. I have chosen emotion recognition system and hand gesture recognition system to actually give the instruction to the computer. And this is the application area. Keyboard and mouse operation can be controlled with this system. It is useful for disabled people, and it can be used for application control and the humanization of artificial intelligence systems. In the first literature review, they have built a system to control VLC media player, but their accuracy was very poor. And in the next literature review, they have actually used to detect the skin color and then remove the face from that frame, and then they used that hand to track actually the movement of the hand up, down, left and right in 4 direction. And in the next literature review, they have counted the number of fingers to actually give 4 instructions to a robot to control it. And in the next literature review, they have actually counted the number of fingers and also the direction of the hand to actually produce more gestures. And in the next literature review for facial expression recognition, in this system, their proposed system actually use an average weighting method to actually reduce the errors. And in the next literature review, they use a pre-trained facial landmark detector for feature extraction to reduce the computation time, and the accuracy actually was low in this case. And in the next literature review, they have used CNN for actually subtracting the background and detecting the face from that frame or video frame, and then they have used that for feature extraction so that there will be less error in that system. And after that, they use another CNN model for classifying the emotion on that face. And this is the objective of the system: to obtain touchless interaction between human and computer, to give instruction via the hand gesture and facial emotion recognition system instead of the input devices, and to control different applications like a video player, music player, or PDF reader, PowerPoint presentation, etc. with the help of this single system, then because we are giving this instruction via the keyboard. So this is the actually flowchart of hand gesture recognition system. And first the input will be captured, then pre-processed, then hand will be detected, then image enhancement technique, then thresholding, feature extraction and classification, and gesture recognition and action generation. So after the video is captured, the skin color object will be detected, then the face will be removed, and you can see this image here, only the hand will be remained inside that frame. And after that, we will create a threshold image that will be actually binary image, where the hand's skin color object will be actually shown in white and other things will be shown in black. And after that, we will find the contour or draw the contour around that hand. Here you can see the green line actually means that the contour, and then we will draw a polygon that is called convex hull around that hand. And you can see some portion of that convex hull is not actually the main part of our contour or main part of our object. Here it means hand. So this is actually called the convex defect, and here you can see this yellow dot, that is actually the depth point or the far point. And we can actually find start, end point and far point from this convex defect. And here we will use that we use those 3 points to actually draw a triangle like this one in our hand, and from there we can actually use the cosine rule for calculating the angle between these two fingers. And this, if this angle is less than 90 degree, we are considering it as a defect, and if there is a defect, then we can actually use this equation, finger equal to defect plus 1, and using them we are actually counting the number of fingers. And now after that, we need to actually track the movement of those fingers or hand. There we can actually I have actually found the center of the hand and then track the movement of that point in the x-axis and the y-axis for 5 seconds. And after that, I have actually predicted the direction the hand are moving, and then combining them together for 5 fingers, there are 4 directions. So I can generate 20 different gestures from this system. So this is facial expression recognition system's workflow. At first, the user's face will be detected from the frame that we are getting receiving, that the computer receive, and then they will actually recognize the emotion from their face and then generate an action. So I have used convolutional neural network instead of multilayer perceptron, because in the multilayer perceptron, if the image is very large, then managing those weight will be very difficult, and if the image is flattened, then many information can get lost in the process. So instead of hand engineered process of feature extraction, CNN actually take the raw pixel of an image and learn to extract the features through training. And we need a data set. I have used FER 2013 from Kaggle FER challenge. There are around 29,000 images for training process and 7,000 image for testing process. There are some problem in that data set also, like imbalance problem, as in there are 400 images for disgust class and around 7,000 image for happy class. So the trained model will be actually biased toward the happy. There are some other problem also, like contrast, variation, occlusion, eyeglasses, and this problem can be actually reduced by using some pre-processing. I have used data augmentation for removing this imbalance problem. In the data augmentation actually creates some artificial images, and by rotating, flipping horizontally or vertically, then zooming, then changing the intensity, etc. So this is the pipeline of the system, facial expression recognition system, and here the input frame image sequence or video frame will be actually sent for the pre-processing, and after that it will be sent for training process, and here we will send it for to the CNN to train the model, and after the training process we can use this model for testing purpose. The image will be actually captured, and then it will turn into gray image, and then the face will be detected, and then after that we will use the trained model for predicting our facial emotion or expression. Then after that the output will be actually sent. And there are 4 convolution layer and 2 fully connected layer and an output layer. CNN model actually has 2 parts. One is feature extraction part, another one is classification part. This convolution block actually used for feature extraction, and the fully connected layer and output layer actually classify the main object, or in this case our facial expression or emotion. So the convolution layer actually reduces the size of an input image by taking the most important feature and excluding all the others. And in this case, they actually use a feature detector or filter that traverse through the whole image, and then after that they actually give us a feature map that will be used for further processing. And in this case, and in the initial process, the feature detector actually detect the edges of an object inside that image, and in the deeper process they actually find the cause of an object. And after that they actually there is another process called max pooling. These actually reduce the dimension of an image, hence the parameter of that image, and the computation time actually reduced because of this, and it takes only the most important feature from a region. Like if that image has a 2x2 region, from all these 2x2 regions they will only take the maximum from there. And dropout actually means randomly selecting some neurons and then completely ignoring those neurons for this is actually done to avoid the overfitting problem. And here we can see this from this picture. And after that the ReLU, this actually means increasing the non-linearity, because most of the natural images are non-linear, and these actually decide if the neuron will fire or not. In the last layer of the convolution layer, there is a process called flatten that actually makes the whole image into convert the whole image into a one-dimensional array that is connected to the next fully connected layers neurons. Each node will be connected to each other, and then after that we have used a softmax function in the output layer that actually give a normalized probability to each class, and the class which has the maximum probability is the predicted output. In this case we can see that the dog has the most probability value, that is why this is the output class. And in our case there will be we will check which class has which emotion or expression has the most probability value. This is actually the workflow diagram of the complete process. And this is the result of the hand gesture recognition system, and the accuracy was around 97% for detecting the number of finger and their direction. And here we have actually used to give the instruction via the keyboard to actually control different functions for different applications. And this one system can actually control multiple applications because we are giving the instruction via the keyboard instead of a particular application. The 3 finger is shown in front of the camera while the video is running on a application, or it becomes mute. And here you can see the output of his output of controlling the PLC media player, where the volume will be increasing when the 4-finger will go upward, or if 2-finger move forward in the right direction, then video will fast forward. And for me, it's terrifying blazing speed. And if forefinger go downward, then volume will actually decrease.
Did you see that? Oh, ready to make some.
And we can also control the presentation slide with the same application, with the same system. Here you can see when 5 fingers are showing, the slide is changing. And this is the result of the facial expression recognition system. The model was trained for 7 classes, and the training accuracy was around 90%, but the testing accuracy was around 68%. Later used only 5 different emotion, and for 5 emotion the testing accuracy actually increased around 89%. And then the result of the facial expression recognition system. And this is actually the application of using both the system together. You can see here, if 5 finger and a happy face is shown, then they will actually launch the Google Chrome and search for new happy movies related to that emotion. And like that we have actually used those combined system. So in the future we are going to use CNN or finger detection also to remove the intensity problem. And then we will use some different method and data set for actually training our model, so to increase the testing accuracy, and we'll be applying this system for controlling more applications. And this is the reference